So hi guys, I hope you are doing well or extremely well. Now let's continue with the chapter of differentiation and derivation. So I'm going to assume that you have no prior knowledge of differentiation because this video will be seen by every kind of student. So I'm just going to assume that you have no knowledge of differentiation or derivation for the matter. Okay, so in your simpler version of maths and your boards, you might have studied how to calculate the gradient of a curve. All right. Because a curve has many different points and at every different point the gradient changes. A curve has no constant gradient. Unlike a straight line, a curve doesn't have a gradient, a constant gradient. All right, so how do we calculate the gradient? Well, you just draw a tangent at that specific point at which you want the gradient of. You draw a tangent, you take 2 points from the tangent, and then you calculate the gradient. All right, so that's the mechanism. But now you are grown up and now you are going to study a higher advanced version of maths, and that's not how you take the gradient. For your accurate gradient, that's just not how you do it. What you do is you basically calculate the derivative function. So if you're given a curve, if you're given an equation of a curve, what you do is that you simply take out the derivative. You simply take out the derivative function. So you take out the derivative function, all right? And at any point, at any specific point on which you want the gradient, you put the x coordinate. So you put your x coordinate in your derivative function, all right? So you put the x coordinate in your function, in your derivative function, and then you finally you get your gradient at that point. So if I want derivative or basically the gradient at point P, what I will do, I will just calculate my derivative function, and then I will put and then I will plug in my value of x coordinate of P, right? Of P, and then finally of, of P, all right? And then finally I will get my gradient at P, all right? Similarly, for any different point, you will just put your x coordinate of that point in your derivative function, in your differentiation function, and then finally you will get your gradient at that point, and that is how you do it. That is basically how you do it. So first of all, before we proceed or before you jump on to questions regarding this specific concept, we need to understand how do we take the derivative, how do we take the differentiation, how do we do differentiation basically. So we need to understand some of the rules of differentiation. And so the first rule which we will be discussing or learning is the function of constant. So derivative of a lone constant is always zero, always and always zero. For example, derivative of 3 is 0, 4 is 0, 22 by 5 is 0, and again -8 is 0. All right, so derivative of a lone constant is always 0. So that's our first rule. Our second rule is derivative of our variable is the coefficient. What do I mean by that? Well, just take a look at it. Well, we are going to just take a look at it. For example, if I were to calculate the derivative of 3x, well, it will be 3. 4x will be 4. 22 by 5 will be 22 by 5, 22 by 5x, all right? And similarly, -8x will be -8, all right? And also, you just need to take a little bit of a look at it. All of my x have a power of 1. All of my variables have a power of 1. So for this rule to be applicable, your power needs to be 1 for your variable. And now let's take a look at a little advanced rule, the power rule. Okay, well, what does it mean? It basically means if you have a bracket and you have a power on top of the bracket, which let's denote it by n. And your box, well, I'm just going to assume there's a box here, right? A term which is my box. So any term which has a power on it, our powers is basically our power is on top of the box. Our term will be called the box. Let's just assume it as that. Okay. So when I take the differentiation, or let me write it dy by dx, what will happen is simply my box will remain as it is, but there will be a little bit of a change. And let me use, a dotted version to show my power of n will go behind. All right, my power of n will go behind. So it wasn't really that difficult. And so it remains the same. So n goes behind, and my bracket and my box remains the same. And a power of 1 is subtracted from my power of n. So n minus 1, and then it is multiplied by the derivative of the box. All right. So it is multiplied by the derivative of the entire box. So that's basically the power rule. Well, I know you guys didn't understood in the first glance, but before that, before just jumping onto it, let's solve some other questions to better understand the concept. Well, for my first two rules, I'm going to solve two questions to just give you a little bit of a analysis. Okay, so I know my x with a coefficient of 6, well, the derivative of a coefficient and alone variable, the derivative of an alone variable is its coefficient, so it will be 6. And let me just highlight it, it will be 6. And similarly, the the derivative of a lone constant is 0. All right, so it's 0. Similarly, for my derivative of y is equal to 3x minus 4, well, the derivative of an alone variable is by alone variable I mean the power of 1. A variable with a power of 1, for the derivative of a variable with a power of 1 will always be its coefficient. So again, it's 3. And similarly, negative 4 is 0 because a lone constant is 0. So 0. Okay, so my final answer is 3. Similarly, now let's apply our power rule. So again, for derivative, we know that our power is 4. So the term on which the power is, the term is basically my box. So let's just highlight my box. This is my box. So power goes behind the box. So it becomes 4 into x, and 1 is subtracted from my power. So it becomes power of 3, and then it is multiplied by the derivative of the box. So what is the derivative of my box? Well, it is x, and alone x. X is alone. So derivative is simply 1. So it's multiplied by 1. So it becomes 4x to the power of 3. So, for example, 4x plus 3 whole to the power of 2, and for my derivative, well, I can see that my box is simply 4x plus 3 because my power is upon the whole of the bracket. Okay? So rules are rules, and power goes behind the bracket or my box. 2 into 4x plus 3, and 1 is subtracted from my power, so it becomes 1. And now the derivative of the box. What is the derivative of 4x plus 3? Well, because x has a power of 1, its coefficient will be the derivative, and so it's 4 plus 0 because derivative of lone constant is 0. Okay, now, well, let me just write it with a little bit of a clarity. It becomes 8 into 4x plus 3. All right. Now, y is equal to 5 under root 5x, 5 minus 3x, right? Now, let's just arrange this question a little bit. Well, because there is an under root present, we know that under root basically represents a power of half. So it becomes y 5 minus 3x, y is equal to 5 minus 3x whole to the power of half. And now rules are rules. And for my derivative, well, let's just write it. My power goes behind my bracket or my box. half into 5 minus 3x, and half 1 is subtracted from half, so half minus 1 is negative half. And well, let me just highlight my box, and that is my box. Okay, so now the derivative of the box. Well, the derivative of the what is the derivative of 5 minus 3x? Again, 5 is a lone constant, so it's 0, and x coefficient is negative 3, so it's simply negative 3. So it becomes half into negative 3 into 5 minus 3x into negative half. So it becomes negative 3 by 2 into 5 minus 3x with the power of negative half. So that's my derivative. So that wasn't really easy. So when you are dealing with denominators, when you have denominators, we cannot differentiate our denominators. So what we can do is that we can take our denominators into numerators. So let's just do that. So it becomes 4 into 9x to the power of negative 1, because through the laws of indices, and I really hope you have already studied indices up to this point, it becomes negative 1. And now I'm going to take the derivative, the differentiation function. So it becomes, well, because power is present and my box, well, let me just highlight my box. This is my box. So power goes behind the box. It becomes negative 4 into 9x. Negative 1 is subtracted from negative 1. It becomes negative 2. And now the derivative of the box, or let me just write it here. Derivative of the box. Well, what's the derivative of 9x? Is simple 9. All right. So derivative of a variable with a power of 1 is always its coefficient. So x with the power of 1, x simply has the power of 1 here. So 9x derivative will be 9, simply. Okay, so 3x plus 9 upon 4x minus 2. So first things first, let's bring our denominator to the numerator. It becomes 4x minus 2 with the power of negative 1. Okay, so now let's take the derivative. It becomes 3x plus 9, and through the power rule, negative 1 goes behind the box, and my box is 4x minus 2. Okay, so simply it becomes negative 1. Well, let me just write it with a bigger bracket. So it becomes 4x minus 2. Negative 1 subtracted from negative 1 becomes negative 2, and multiplied by the derivative of the box. So what is the derivative of the box? It is 4. Okay, because 4x, well, the derivative of a variable with a power of 1 is its coefficient, and coefficient of x is 4, so 4 is my derivative, and derivative of negative 2 will be 0, because it's an alone constant. So it becomes 3x plus 9 into negative 4 into 4x minus 2 with the power of negative 2. So it simply becomes 3x plus 9 with with negative 4x negative 2 with the power of 2. Okay, so that wasn't really difficult, was it? It wasn't really difficult. Okay, so for our final question for this video, well, now we are dealing with two denominators, and it will be a little bit of a it will have a little bit of a complication, but still it is quite solvable. All right, so now let's take our derivative function. Let's calculate the differentiation function or derivative for the matter. Okay, so my box, let me just highlight my beautiful box, and these are my boxes respectively. Okay, so now negative 1 goes behind the box, so it becomes negative 9 into 2x plus 7. Box remains as it is, and my power is subtracted from negative 1. It becomes negative 2, and now the derivative of the box. Okay, so it becomes 2, because 2x, derivative of 2x is 2, and derivative of 7 is 0. Sorry, plus, well, again, negative 1 goes behind, it becomes negative 1 into 5. Let me just put a bigger bracket, and the derivative and the bracket remains the same. The box remains the same, so 7x negative 1, and my power is subtracted from 1, it becomes negative 2, and now the derivative of the box, which is simply 7. Okay, or let me just write 7 negative 0. Okay, because derivative of non constant is 0, and so derivative of negative 1 will be 0. So it becomes negative 9 into, well, negative 18. For the matter, it becomes negative 18 into 2x plus 7 with the power of negative 2 plus negative 5, well, negative 35 into 7x with the power of negative 1, 7x minus 1 whole to the power of negative 2, Okay, so let me just place up a bracket here, and so it becomes negative 18 upon 2x plus 7 whole to the power of square, whole to the power of 2 basically, and negative 35 with the power divided by 7x minus 1 into 2. Okay, so that's my dy by dx simplified. So that's the whole case right now. Okay, and I really hope you guys understood it, and I really hope you guys have a little bit of a clarity on it. So if I just revise my power rule function, because all other rules are quite easy, so my power of n goes behind my box, and this is my box. All right, so whatever term is inside the bracket is my box. So n goes behind and my box remain as it is, and just 1 is subtracted from my power. Okay, so 1 is subtracted from my power, and then it's multiplied by the derivative of the box, and that's the whole differentiation function. Well, at least for now, because things will get just complicated from now on. But if you have a good grasp on these concepts, then it will be quite easy for you. So that's our beginning of solving calculus, solving some of the calculus functions, some of the calculus equations. So I will see you in the next class.